we have a small mistake here. This is 20 centimeter per minute. It's not centimeter cube per minute. It is centimeter per minute. We have to change it because the rate of water level is centimeter per minute. We have to change that. After changing that, centimeter per minute. Then we have to start our calculation. So first of all, we'll read this question and understand what the question says. Before that, we'll import a diagram. It's a cone. This question says about cone. So we're taking a cone and we are going to simplify that cone. Adjust the width and position of it, and again we'll make it a tab. One tab, we'll import a tab 1. Okay, it's a nice tab like this, and we'll adjust the position of it. Okay, and take a bit down. Okay, and scale it a bit, then open up the marker and we'll do it. Then what can we do? We'll zoom it, or yeah, better to zoom it out, and we'll mark the water coming out of tap and going inside the cone, and we mark the water. So nicely you can mark the water. So water will always be in the blue color, but we are marking it in the red color. It's not a big deal. So we are marking the water, and underneath we have to mark the water level of the cone. So we can mark the water level. So your red color, I am marking the water level. Water level, yes, we are indicating, we are not shading it over. Yes, we are indicating by line what is the water level in the cone. So these are the important steps we have to follow while we are writing this. So we have drew a cone, we have marked the water level, and also now the water is also going out. It's also given as water is leaking. So we have water is entering and water is leaking too. Then we'll zoom out. Then we have to write some definitions. So if you read the question, water is leaking an inverted conical tank at rate of 100 centimeter cube. At the same time, the water is being pumped into the tank at a constant rate. The tank has a height of 6 meters and a diameter of 4 meters. Okay, then we have to zoom in and write a definition. Let uh, let let's take the rate of water pumped in as dp by dt. So we are defining like this. Let's take the rate of water pumped in as dp by dt. And secondly, what we are going to define is, let's take the rate of water leaked in as rate of water leaked out as dr by dt. So the water which is leaking out from the cone as dr by dt. And let's take the rate of water level rising up water level which is rising up in the cone as dV by dt. So when the cone, we have taken three type of parameters here, that is dP by dt, dr by dt and dV by dt. The first one is the dV by dt. dV by dt means volume rise, increasement in the cone is defined as dV by dt, and dV by dt is the question, the rate of water pumped in, and dr by dt is water leaked out. After that, we are going to mark it. Here we are going to demonstrate. This is dP by dt, that means water pumped in. Then here we have to mark it, the water level rise up dV by dt, and again the water which we deliver, that means leaking out, that is dr by dt. So the three values, three rates are be marked up. After that, what we are going to do is we are going to read the question again, and we are going to extract the values from that, and we are going to put up a note. So what we are going to do, we will read the question again. So here what we can see is we have marked all the values given, and we will put up a note. The height of the cone is given as 6 meters. We have to mark it up. Let's take it 6 meters, and we have to mark another data is given with the height, the radius also we have to can't forget the radius also. We have to mark the radius of the cone is also 2 meters. The radius is 2 meters because the diameter is 4 meters, so we have to mark the radius is also 2 meters. Then we have to consider the another important data which has to begin when height is given, means important data is that dh by dt, when h becomes 2 meters, the dH by dt, the rate of increment of water level, it's not dr, sorry, we have to take it dH by dt, the rate of increment of the water level, dH by dt, which denotes be 20 centimeter cube, 20 centimeter per minute. This is the mistaken value we have marked in here, 20 centimeter per minute. We have to mark it out. So these are the things what you have to show in the beginning. When this is the important things. Most of you can write the answer, but the steps what you have to follow is important while you are answering the questions. So we have answered everything. So dP by dt, dV by dt, dr by dt we have marked, and we have denoted that. So first of all, what is our question? We have to understand what is the question. So question is, we have to find dP by dt. This is our question. So this is dP by dt, the question. We have to find the dP by dt. So where we have to begin? We have to begin from the dr by dt, because dr by dt is our data. Then we have to find dV by dt. From dr by dt to dV by dt, we have to come from that. So from dr by dV, drt over dt, or we have to come from dV by dt. From that we have to go to dP by dt. So first of all, we need to find dV by dt, because dr by dt is given as 10,000 centimeter cube. So we must start from dV by dt. To start from dV by dt, we have to take small diagram. So let's find dV by dt. Finding dV by dt. Let's write it down and underline it. After that, what you're going to do, we need a diagram. So I'll try to take this cone up, but I'm trying to take this cone, but the problem is selecting it. It's a bit difficult. So try to paste it here. Oh, sorry, I didn't get it. So try it again. Okay, I got it. I copy and paste this cone. Yeah, I got the cone. So we have the cone here. So first of all, what we are going to do is I'm going to mark the some values and information of data which is given about this cone in the cone diagram. So what we are going to do, let's take some ruler for the measurement, or we will first start with the marking the water level. So water level I am going to mark with the green one. Green is a nice color. You can see we can denote it nicely. So we mark the water level. After that, what we can do, we can mark the heights of the different lengths, radius and heights and others. So what I can do, I'll mark some positions using a ruler. So it might be the height, this might be the radius, and if you come to write the mark in the same way, this is value. It might be, I think it might be 2 meters and 6 meters. Um, so what we can do is we can check it again. So what we have done, yeah, is again 6 and 2 is confirmed, so we can write values. This is 6, again this is 2. We have denoted the values. After that, what we can do, we have to mark the length and height and the radius of the small water level here. So we have to selecting and indicating that level, we have to indicate it. So what we have to drawing two small lines over there, and we are going to mark that upper one, the radius, as simple r, and this as h. So we have two triangles, so we have to apply similar triangle principles, so that we have to take the semi-vertical angle of this cone as alpha. Yes, for this applying the similar triangle principle, we have to take that as alpha. So what we can do is can apply the similar triangle principle. So by similar triangles in the diagram, we can say, scale a bit, we can see what we can say, this is our level work. We can say about r over 2, by considering two triangles, r over 2 equal to h over 6. This is a similar triangle principle, so we can simplify denominators and we'll get r equal to h by 3. So we're going to take this as equation 1. What is the reason we are subjecting the r equal to h by 3? Why we can't subject h equal to 3r? Because we have only have the dh by dt and h value. We don't have any relationship with the r. So it's better to subject r. Then we'll go to the volume, and v equal to 1 over 3 pi r squared h, and we substitute for r equal to h by 3 and squared of that and h. We will further simplify that one, and what we get is 1 over 3 pi h cube, get h cube over 9. And for the simplification, we'll get again, we'll go to next page. V is equal to, my v is not exactly correct, so okay, it's very difficult to write with the mouse. Okay, v is equal to pi h cube over 27. This is my final expression for the volume, what I get after submitting radius. So what we are going to do, we are going to differentiate this function with respect to time. So let's write it. Differentiate the function with respect to w dot r dot t. that deforms for with respect to t, time t. So what we are going to do, we are going to differentiate v with respect to time t. We'll get dv by dt, that is equal to pi and 27 are constant. Let's keep it like that and differentiate h cube. This is called implicit differentiation. Then 3h squared into dh by dt. We are differentiating h with respect to h and then differentiating h with respect to t. Then we further simplification will get pi by 9 h squared into dh by dt. After that, the value is dv by dt. So we know the value of h and we know the value of dh by dt. So we can substitute that values and we can find the value for dv by dt. So what are the values of that one? H is given here. When h tends to 2, the dh by dt is 20. So substitute those things. But we have to very careful. There will be made some mistakes. Probably you can make the value of h. Here h, this h is in the value they given in meters. We have to convert into centimeters. Very carefully you have to do that one. If you put into the meters, you will get a wrong value. Here 2 meters, but others are given in centimeters. If you put into in meters, you will get the wrong answer. Be careful about unit conversion. Then what you can do is substitute the other values. Pi by 9 into 200 whole thing square into 20 will you give the answer. So simplify further. Pi by 9, you can simplify it. Pi by 9, let's write it. Pi by 9, if you simplify 200 square, that is 40,000 into 20, that will you give about 800,000. Pi over 9. Let's write it out. So this is our dv by dt. This is in centimeter cube per minute. This is one of the rate, that is dv by dt. So we had 3 rates, we found 1 rate. So we are very close to the answer now. So I need to explain what is the real theory behind that one. So we are going to move the next part. So we have find dr by dt is given, dv by dt we found that. Now we can go to dp by dt. So we have to take the diagram again to explain it. So I'll zoom out and try to again pick up the diagram with the tab. I'll try to take it. Okay, I'll change to new page and paste it up. And again I didn't get it exactly what I want, so I'll undo it and I'll try to take only the cone again and I'll copy that one. Try to copy it. Okay, copy the cone again and paste it here. Yeah, we have the cone. Then we'll mark randomly, pick up a color and we build a small tab here. Yeah. So imagine this is our tab. So we'll zoom a bit and mark the water. So water is coming like this, and we have to mark the water level too. So we can mark the water level. The water is coming around. After that, what we have using the general color to mark the water. So water, we have marked the water. Water level marking is important. So water also leaks out from here. We have to mark the water level which leaved out. So we have to mark both of these values. Then what we have to do, we have to mark rates, dr by dt, rate of dp by dt, the rate of water pumped in. Then this one is dv by dt, that is water level dries up. This is water level leaked, that is dr by dt. So basic theory behind this is the important fact in this thing. Dr by dt. So what we are going to do, theory, the rate of volume rise. We have to write it. The sentence you might write is better. Rate of volume increase is equal to rate of water pumped in. Rate of water pumped in minus rate of water pumped in, negative is important, minus rate of water leaked out. After that, what we can do, we can convert this expression into symbols. That means dv by dt will be equal to dp by dt, dp by dt, that is dp by dt, negative dr by dt. We have to write dr by dt. So our question is dp by dt. That is our question, right? We have to find dp by rate of pumped in, water pumped in. So we have the one equation, we have the one unknown, we can find it out. So dp by dt is our question, let's subject that one. So dp by dt is equal to dv by dt, therefore dp by dt is equal to dv by dt plus dr by dt. So we can substitute, we know dv by dt, we know dr by dt, we can substitute and go to the final answer. So let's go to the other page and write it. dv by dt is how much? dp by dt is equal to dv by dt. How much the dv by dt? The value which we have found, that is 8,800 pi over 9 centimeter cube per minute. 800,000 centimeter cube per 8,100 pi over 9 plus dr by dt. Dr by dt is given in the question. You can see that is 10,000 centimeter cube per minute. So that is 10,000. Let's take a color and highlight it. That is 10,000 centimeter cube per minute. Take that value and substitute here. 10,000 centimeter cube per minute. Okay, both are in centimeter per cube minute. This is our final answer. Then we can simplify it more. So what we can do, dp by dt, 10,000 is not clear, write it again. 10,000, okay, it's perfect. 10,000. So I can further simplify it. 800,000 pi five zeros, okay, pi over 9 plus 10,000 centimeter cube per minute. Again I put an extra zero, easy, remove it. Okay, sorry, I can close the bracket, we close it, centimeter cube per minute. If you further simplify that one, it will approximately equal to I guess the value I think my calculations is my 289 comma 253 centimeter cube per minute. That means 289,253 centimeter per cube per minute. This is your final answer which you might get. This is the final answer for this question number 2 in the assessment. So let's take a review from the beginning how we have to took the answer. So read from the question. Water is leaked out from inverted conical tank at the rate inverted the conical tank the rate of 10 centimeter cube. At the same time, the water is being pumped in a constant rate. The tank at 6 meters. There is a height is 6 meters and the radius is for 2 meters because diameter is 4 meters. And there's a mistake here. It's centimeter per minute. We have to change it. Then we are getting this dp by dt and we are defining all the values, and let's take the rate of the water as dp, pumped in as dp by dt, and then let's take the rate of the water leaked out as dr by dt, which is the bottom one. Then let's take the water rise in as the water level, which rise as dv by dt, which is rising, and we have denoted the rate as, and we have marked it out. Then height of the cone as 6 and radius is 2 meters, and when h is equal to 2, what is the value is given, when h is equal to 2, the dh by dt value, that is 20 centimeter per minute. Very careful. So our question is dp by dt. So find the dp by dt, our question. To find dp by dt, dr by dt value is given. So we have to go for dv by dt. From that we have to go to dp by dt. That is our target. So we have to find dv by dt. So finding dv by dt. To copy the diagram. So we have to marking all the values and data here, and we are going marking the semi-vertical as alpha, and r and h and 6 and 2 have marked. And by going to similar triangle principles, I wrote this alpha over r over 2 equal to h by 3. By going to considering the similar triangles, I have write it, and I simplified those things, and I got r equal to h by 3. Then I got, what I did is I wrote the volume expression for the volume. Volume of the sphere cone is equal to 1 over 3 pi r squared h. 1 over 3 pi into for r squared I substitute h by 3, and I get 1 over 3 pi h cube over 9. Then after simplification, v is equal to pi h cube over 27. So then I differentiate with respect to time. Then dv by dt is equal to pi over 27 into, I'll use a constant, I keep that one, and 3 into h square, and dh by dt because it's an implicit differentiation, and again pi over 9 is h square into dh by dt, and all the values are given because h tends to 2 dh by dt is 20. We have to substitute those values here. Then that is in careful because that is in meters. We have to convert the centimeters and substitute those values. Get 40,000 into 20. We will get 800,000 pi centimeter cube per minute. So we have to find question dp by dt is our question. dr by dt is given. We have to find. We have this one. This is our target. So rate of the volume is increase is equal to rate of the pumped in minus rate of the water leaked in. Is our concern. This is the important equation, but be little bit confusing. So what we have to done, then again what we have to done, we have made that into simples, and dv by dt is equal to dp by dt minus dr by dt. Therefore dp by dt is equal to dv by dt plus dr by dt. Then what we have done, we have substitute the values. Then dp by dt is equal to 800 1000 pi plus 9 plus the value which is given, that is 10,000.